Hi everyone, it's time for the second lecture of matrices. Now I'm hoping that you've learned nicely in the first lecture of matrices that we've got 7 types of matrices in our syllabus. The first 4 that we covered, let's revise them. First is which? Row matrix. It has only one row. Next, column matrix, only one column. Rectangular matrix, where the number of rows and number of columns are not equal. And the last one that we learned was square matrix, where number of rows and number of columns are obviously equal. Alright, and we obviously learned some basics of matrices. What is a matrix? It is arrangement of numbers in rows and columns. Yes, I hope you're recalling with me. Enclosed in square brackets, correct. Then we write the order towards the right bottom of the matrix. First we write the number of rows and we write the number of columns. For example, it could be 2 into 1 or 2 cross 1 and so on. Correct. That was the revision of last lecture. Time to start ahead. So in types of matrices we covered 4. Let's go about the fifth one. Fifth matrix is called as diagonal matrix. So what is a diagonal matrix? First of all, I will say diagonal matrix is a square matrix. That means the order needs to be 2 cross 2 or 3 cross 3, like that. That means number of rows and number of columns should be equal. So diagonal matrix is a square matrix in which all the elements except the primary diagonal elements are 0. What do we mean by this? Let's see. First of all, to understand this, let's recall a normal square. So in a normal square, okay, this looks like a rectangle. I'll take something like this. Now in a normal square, what happens is we call such a thing as diagonal, and also this I call as diagonal, correct? Now if I call this as ABCD, AC can be called as primary diagonal and BD can be called as secondary diagonal. AC is primary and BD is secondary diagonal. BD is a secondary diagonal. Now, going ahead, this says diagonal matrix is a square matrix. So first of all, let's take a square matrix. For example, 2 cross 2, 1, 2, 7, minus 8. Now, it is a square matrix in which all elements except primary diagonal elements are 0. Who are primary diagonal elements here? These are primary diagonal elements here. Check it out here, like AC. These are diagonal, primary diagonal. So, except these two, rest all of them should be 0. So, is this a diagonal matrix? No. Okay. So, A here is not a diagonal matrix. Let's take B. 2 cross 2. Well, let's take this as minus 7, this as 23. And if I take these both 0, can I call this as diagonal matrix? Yes, first of all, it is square. Secondly, the non-primary diagonal elements are 0. So I'll call it as a diagonal matrix. Okay? I could also take a 3 cross 3 matrix. Let me call it as C. These elements need to be some value except 0. For example, 22 minus 28. I'll wait for this and I'll call these all as 0. So if I write here any number, you will say it is a diagonal matrix, yes or no? What if I write here 0. My question is, will you still call it as diagonal matrix? Think. What do you say? Will I call it as diagonal? No. But if I write it as 20 or anything else, will I call it as diagonal? Yes. Clear? Next one. After diagonal matrix, simple matrices we have 0 or null matrix. So let's see what is a 0 matrix or a null matrix. It's very simple. 0 matrix or a null matrix is a matrix whose all elements are 0. Doesn't matter it is square, rectangle, this, that, row, doesn't matter. All I need to check if all the elements that are present should be what? 0. It could be this. All of them are which matrices? 0 matrices or null matrices. Only one condition. All the elements should be 0. Next one. Identity matrix. Identity matrix is also called as unit matrix. Now what is identity matrix or unit matrix? It means if I define it, it says it is not just a matrix, not just a square matrix, but it is a diagonal matrix. When I say this, it automatically becomes square matrix because diagonal matrix is a square matrix. Okay. So identity matrix is a diagonal matrix in which all primary diagonal elements are 1. That's a condition. So if I take a rectangular matrix and make diagonal elements 1, is that okay? Not at all. First of all, it is a diagonal matrix, which means it should be a square matrix, and which means all the elements must be 0 except primary diagonal. And further condition he puts is in which all primary diagonal elements are specifically only 1. That means it looks something like this in 2 cross 2. 1, 1. Rest of them need to be 0. I can't write any other number here, not even -1, not even 0, nothing. This is what we call as identity matrix. I can take 3 cross 3 also. So that becomes 1, 1, 1. Rest of the elements 0. So this is 3 cross 3. This and this, I'll call it as identity matrix. Very important one. Keep in mind. Here we finish the types of matrices. Let's revise all 7 types together. First, row. Second, column. Third, rectangular. Fourth, square. Fifth, diagonal matrix. Sixth, 0 or null. Seventh, identity matrix. Row means you know it. Column, you know it. Rectangular, you know it. Square, you know it. Let's revise these 3 that we learned today. Diagonal matrix. It is a square matrix in which these elements should be non-zero, rest of them should be 0. Next, 0 or null matrix, simple. All elements should be 0. No other condition. Identity matrix, or also called as unit matrix, means these needs to be 1. All of them except these should be 0. So it is a diagonal matrix in which primary diagonal elements are 1. Next, further that we'll understand is something called as transpose of a matrix. It's very simple. Name is complicated, but it's actually very simple. So what is transpose of a matrix? Transpose of a matrix means if I have this matrix A, 1, 2, 3, 4, I can take transpose of this matrix A, which means I can turn the elements present in row 1 into column 1. Elements present in row 1, I'll write them in column 1. So 1 here, 2 instead of here, I'll write it here. Similarly, elements of row 2, I'll convert them into column 2. So that becomes 3, 4. That means interchanging of rows into columns. In other words, interchanging of columns into rows is called as transpose of a matrix. So this resulting matrix is nothing else but transpose of this matrix A, which is denoted by A raised to capital T or A raised to dash, one and the same. It's very simple. Convert the rows into columns, that's it, forget everything else. Then I call this matrix as transpose of this. So does that mean if this is transpose of this, does that mean this is transpose of this? Check and tell me. And the answer is yes. Because if I take this row, convert into column, yes, this row into column, yes, one and the same. Got it? So transpose means interchanging of rows and columns. Next. Equality of two matrices. Now we say that two matrices are equal if, number one, they have the same order. Order is same. Second, corresponding elements are equal or same. Equal is a better word. We say that two matrices are equal if they satisfy two conditions. First condition, very important, order should be same. Second condition, the corresponding elements should be equal. For example, if I have a matrix A which is 1, 2, 3, 4 and there is matrix B which has 3 elements. Can I say these matrices are equal? Answer is straight away no. Did it satisfy this condition? No. Order here is 2 cross 2, but here is 1 row and 3 columns. So they are not equal. I'll say A is not equal to B. But if I take C, which is 2 cross 2 again, I write here 1, 2, 3, minus 4. First condition satisfied? Yes. Second condition, corresponding elements should be equal. Corresponding elements. Yes, same. Yes. Yes. Are they equal? No, they are not equal. So that means are matrices A and C equal? No. But if I remove that minus and write it plus, can I now say A and C are equal matrices? I'll say yes. Matrice A is equal to C. Clear? After the types of matrices, we learned 2 more things. Transpose of a matrix, interchanging of rows and columns. Equality of 2 matrices. Order should be same. No. And corresponding elements are equal. Are they equal? Yes. I'll call it as A is equal to C. Matrix A is equal to C. Let's go ahead. So the next thing that we'll learn is called as scalar multiplication. For example, if I have a matrix A which is nothing else but example 1, 2, 3, 4. Now scalar multiplication means simply multiplying with a real number. For example, it could be minus 2. It could be minus 48, 220, minus 7, 2 by 3, and so on, whatever. So if a was 1, 2, 3, 4, now minus 2a, I should write it on the next line. Therefore, I'll say minus 2a, this is how we multiply a scalar, that means real number, with a matrix. What happens is this minus 2 gets multiplied with all the elements of the matrix. So minus 2 into 1, minus 2, minus 2 into 2, that is minus 4, minus 2 into 3, minus 6, and minus 8. So this matrix is minus 2a matrix. This is a matrix. This is called as scalar multiplication. Very simple. Scalar means just multiplication with a real number. And that real number should be multiplied with all the elements. Simple? I hope it is simple. Alright. With this, we end with the basics that we need to understand for today. Okay, I'll stop it here. See you soon. Thank you, everyone.